Today we're going to do a lesson on solving multi-step equations that involve fractions and decimals. So to begin, our first step is going to be to find the least common denominator. In our case here, our least common denominator, or LCD as I'm going to refer to it from here on out, is 12. And it is 12 because 2, 3, and 4, if we list our multiples, we go 2, 4, 6, 8, 10, 12, 3, 6, 9, 12, and 4, 8, 12. So they all have 12 as that smallest common denominator. Once you get past that, finding that least common denominator, then we move on to step 2. Now there's two different methods, which is why that green dotted line is there. Our first method that we're going to do above the dotted line is to multiply by the least common denominator using the golden rule, doing it everywhere. And then this essentially clears the denominator. So what I'm going to do is I'm going to make note of that. Clears the denominator. So when we do that, we have here x over 2, and that is going to be multiplied by 12, and I'm going to put 12 over 1, so it's like multiplying fractions, minus 1 over 3 times 12 over 1, and that'll be equal to 3 over 4, also times 12 over 1, because like we said, what you do to one side, you have to do to the other side. So then when I do that, I notice that I can do some canceling. So 2 and 12 have a common factor of 2. 2 divided by 2 is 1. 12 divided by 2 is 6. That leaves me with x times 6, which is 6x. I see 3 and 12 can both be divided by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. And that leaves me with 1 times 4, which has a minus sign, so that's 6x minus 4. And then looking at the 3/4 times 12, 4 and 12 have a common factor of 4. 4 divided by 4 is 1. 12 divided by 4 is 3. And we are left with 3 times 3, which is 9. And now we've cleared out that denominator. We don't need to put any 1s in the denominator because they don't matter. So we can now go about solving this. And so I'm going to create my plan of attack, since I know that is helpful to most of you. X is first being multiplied by 6, and then it's being subtracted by 4. So when I do my U-turn, I'm going to undo minus 4 with adding 4. And then I'm going to undo multiplying by 6 by dividing by 6. So when I add 4 to both sides, that cancels these 4's and leaves me with 6x equals 13. Then I'm going to divide both sides by 6, leaving me with x. And as I've mentioned before, you can leave 13/6 as 13/6, being that we cannot simplify it. Now what I'm going to do is I'm going to do the second method with this same problem, so that way you can see how it gets you the same solution no matter what you do. The second method is going to be to change them all to equivalent fractions using that least common denominator, and then use that to add and subtract. So when I do that, I have here still least common denominator of 12, and I have x over 2, and I'm going to get it into 12, which is times 6, so I end up with 6x over 12, and minus 1/3, and 1/3 I needed to multiply by 4, so that means I'm going to have 12, and then I take the 1 times 4 to get 4, and I do the same thing on the other side. 4 times 3 is 12. Therefore, 3 times 3 is 9. Now, one thing that you probably have noticed is that you get the same thing in the numerator here as you did when you cleared the denominator in the first method. So we now go ahead and we add across the top, so we end up with 6x minus 4 all over 12 equal to 9/12. Now, we'll get into proportions the second half of this unit, but it is similar, in fact, that because we have this 12, we can say, well, I've got this plan of attack that first x is being multiplied by 6, then subtracted by 4, and then divided by 12. So when we do our U-turn, we end up with multiplying by 12, adding 4, and dividing by 6. So first we'll multiply by 12, which clears our denominators on both sides, leaving us with 6x minus 4 equal to 9. And then we're back where we started with the original problem, with our adding 4 to both sides to get 6x equals 13, and then dividing both sides by 6 to get x equals 13/6. So to summarize what we just did, after we've done that, we will use our order of operations to come up with our plan, and then we use the golden rule of algebra to cancel the operations and solve, finally repeating as necessary till we got our answer. Now personally, I prefer to use the clearing the denominator method, so that's what I'm going to use for this next example. I look here and I have h over 3 plus 4 over 9 is equal to 6. 6 is over 1. So our LCD is going to be 9, and the nice part about having a whole number is that that least common denominator can be whatever you want. I have to multiply everything by 9, so we have h over 3 times 9 over 1 plus 4 over 9 times 9 over 1 equals 6 over 1 times 9 over 1. When I go to cancel, I see 3 and 9 divisible by 3, get 1 and 3. 9's cancel to give me 1's, and we have 1's already in the bottom. That results in 3 times h, which is 3h, plus 4 times 1, which is 4, is equal to 6 times 9, which is 54. So then I can subtract 4 from both sides, which gives me 3h equals 50, and then I divide both sides by 3, and 3 can't go evenly into 50, so I will leave it as h is equal to 50 over 3.